Welcome to Unit 3, Day 5. This video will cover the first page of today's notes, which includes the simple factoring method. If you would like to see the snowflake example, you should stop this video and go on to the next one. To recap a little bit, we've been talking about factoring, and this topic is a little bit separate from the other quadratics units so far, but they will connect as we move forward. And we want to just take a day to review this really important skill. And the skill is factoring. So we have these three different terms that we've looked at before. Divisible means can be divided. For example, we could say the number 24 is divisible by 6. Of course, that's not the only number it's divisible by, and if we want to take 24 and split it into two numbers, there are a bunch of different ways that we could do that. But 6 and 4 would be 1. Another way to understand the same information would be to use the word factor, which in its noun form means a thing that can be multiplied to equal something else, in particular a number. For example, 6 is a factor of 24. And you may notice, of course, that the bigger number comes before the word divisible, and factor in some ways is the opposite. Now, today we're going to look at the same word factor, but in its verb form. And to factor is a verb. It means to rewrite something as a multiplication problem. We've just done that with the number 24. We could do it with the number 18 as well in a number of ways. For example, -1 times 18. Just like we could write 7 as 7 times 1. But the goal here is to actually factor quadratics. And the first strategy for simple factoring is going to be to convert a standard form quadratic into a product of binomials. So what this means is we're starting with something that looks like ax squared plus bx plus c, because that's what it means to be in standard form. And we want to rewrite it as a multiplication problem, but it's not just going to be a multiplication with numbers. We've got some variables in the mix. So the answer to a factoring problem is going to look like this, and this should look familiar from Algebra 1. In order to do so, the first method is really just to use the opposite of what we do in our drills. And so this method, which is sort of a mental math strategy, is useful when you see that a equals 1. In other words, the leading coefficient, either you don't see 1 or it's the number 1. And that's what the first example will show you. And then there's another option, which is if there's a GCF, if you see a GCF, and you can take it out, then you can still use this strategy. So looking at the first example, I know that my answer should look like a set of two parentheses, which will ultimately be binomials. And I also know when I multiply them together, the first term in each binomial is just going to be an x, because x times x will equal x squared as I FOIL it back out. The challenge is to fill in the back, and we have a rule for filling in the back. If you think about what we do for drills, the goal is to find two numbers that add together to equal b. In this case, we want two numbers that add to equal -2. And the same two numbers should also multiply to equal c. If I can find two numbers like that, then we can fill in this FOIL problem in a way that it will ultimately equal what we started with. Because that's what factoring is. It's really just the opposite of FOILing. We're going the other direction. For many people, you can probably already see two numbers that work. In case you're someone who doesn't see these right away, or really for anyone, even if you're someone who can see them in your head, a good strategy for just being quick about factoring is to jot down a quick list. Start with the c value, which in this case is 15, and just make a list of all the products of 15. For example, 15 is 1 times 15. It's also 3 times 5. It's also 5 times 3, but that's sort of the same thing. Now that I'm looking at the actual products, and I'm going to try and zoom here, you can sort of evaluate whether or not these factors are going to be useful to us. Be a little bit conscious of the negative. So if the 15 is going to be negative, that means I must be multiplying at least one negative number. And I can see now that if I turn this 5 into a negative, then 3 times negative 5 will equal negative 15. And 3 plus negative 5 will equal negative 2. So these two numbers, I'm going to fill into the rest of my binomials, plus 3 and minus 5. Or you could have put minus 5 first. The order doesn't really matter. I can check that this is the final answer. If I were to FOIL it back out, I would get x squared plus 3x minus 5x minus 15, which does indeed equal x squared minus 2x minus 15, which is what I started with. And that's to check. This right here, that's your final answer. In my second example, we're going to use a really similar process, but there's an added first step, because I see this time the coefficient is not 1. And so I can't just work this out in my head by thinking about FOIL backwards. But what I can do as a first step is actually to rewrite this same expression by taking out a GCF, which is 2. Each of these numbers can be divided by 2. If I take out the 2, inside parentheses, this quadratic equation turns into a simpler one, which is x squared minus 9x plus 20. And now this is a quadratic equation that I can factor using the same strategy from before, where I brainstorm two numbers. And in this case, I want two numbers that add together to make 9 and multiply to make 20. If it's helpful to make a list, you would start with 20 and list some factors. 1 times 20, 2 times 10, 3 doesn't work, 4 times 5 works. 5 times 4, I realize I have all my factors. And if it's going to be a positive 20, either both numbers are positive or both numbers are negative. In this case, in order to equal a negative 9, I'm going to want two negative numbers. And I can start to see that 4 and 5 are going to work. So x minus 4 and x minus 5 are my two factors. Make sure that you don't forget the 2 out front. This would be your final answer. You should pause the video here and take a moment to solve the questions at the bottom of this page. When you're ready to see the answers, press play again, and we'll continue. Here are your answers.